Good morning, this is Nikhil, and as part of the Sparks Foundation's Data Analysis and Business Analytics Internship, batch February 2021, I am submitting my first task, linear regression to predict student scores from number of hours studied. So let's get into it. First, we import the required libraries such as Pandas, NumPy, and Matplotlib. We then import our data set from the link provided and visualize the first five observations. Now let's visualize our data set to find relationship between the data. So here I have made the plot visualizing R's and scores. The R's versus percentage is the title. So the x-axis shows the R studied and the y-axis shows the percentage score. So there we can clearly see that there's a positive linear relationship between the number of hours studied and the percentage score. Now we shall prepare the data for our linear regression. So we are going to split our data into the attributes and the inputs, that is the dependent and the independent variables. So here we have the x and y which has been split using the ilog command. X contains the R studied, Y will contain the scores. Now using the train test split command from the model selection using scikit-learn, we have split our data into 80-20 training in percent of training and test set. We use a random state parameter to fix the splitting permanently. We now fit our model to our data. As you can see, now the training is complete. Now we will plot the regression line using the coefficient and the intercept. So this is how it looks like. It is pretty clear that the linear regression fits this pretty well. We now use the dot predict command to compute our predictions. Comparing actual versus predicted, we can see the first observation 20 and predicted is around 17, 27, and then it's around 33 is predicted. Now we shall input our own data to see how this predicts. So for 7 hours, if we do the prediction, around 71 is our prediction. Now we shall move on to the last part, evaluating our model. So this step is pretty important to find out how the model is doing. So here we have a few metrics such as mean absolute error, mean squared error, root mean squared error, and R squared. So our root mean square error is 4.64 and our R square is 0.945. So that corresponds to 94.5% accuracy, which is pretty good for a linear regression. Now, lastly, we show the difference between the actual and predicted value through a graph. Yeah, and that's it. Task one has been completed.